All right, another Wednesday and another webinar, but this one with Robert. This one is with Robert Quinn. Sorry, this is the repeat of the record. Actually, we crashed earlier, so we're trying it again. All right, Robert, we good? We're trying again.
The technical guy is having technical difficulties. Yeah, it's our life story, right?
Yeah, it's like a multiverse. It's happening everywhere.
Right, right.
So, another week and another webinar, and this one is with Robert Quinn, and we are covering the whole life cycle. We're covering the full spectrum, right? Hardware and software. Um, you might hear me talk about different AI machine learning, different AI machine learning application use cases, industries. Uh, this is the one that's really important because this is where the matrix actually lives, the infrastructure, the hardware. Because the matrix that we are so fond of, and layer 7 as a user with user experience, it's all happening through the infrastructure, the hardware. And I don't think I can have somebody better than Robert Quinn and come and talk about hardware at this point, because the mad max of hardware that's happening around the world right now, that squeeze, that thirst, that let me have it because I'm dying, moment of semiconductor chips. Robert, let him have it, man. What you got?
And it is a Mad Max world. Gosh, this is. I've been just literally last night. I went to bed at 4:30 in the morning. Just it just doesn't stop, and and I get on the computer at like 11:30, midnight, kind of put the family to bed and try to wrap things up. And before I know it, my computer's just going off nuts. People are calling in and having, let's have a meeting. I'm in Dubai and we need to have a meeting today. And so it is just mad trying to keep up with everything that's happening. I just last week, I mean, you and I were talking earlier about what's all this stuff that's happening. I was talking about the Intel spending $33 billion in Germany and investing another multi-billions of dollars in Poland and investing many more billions of dollars around the world, and other companies converging. Japan investing billions, Korea's investing billions, Taiwan's investing billions, the EU's investing billions. It's just insane watching this. And like, as it was funny because you and I were having this discussion, I was telling you about all these different fabs that are going up and all these different agreements that are happening. And at the end, I was like, "Yeah, this is last week," and you were like, "What? Like, how is this? How is this possible? That this is just last week?" There is an incredible amount of money being moved around the world right now in the semiconductor industry, and it is going to be really interesting to watch as we converge on this. The Semiconductors are the foundation of what you're working on with this artificial intelligence and this new world of technology that's coming at us like a tidal wave right now, right? And so these foundations need to be solidified and built, and being able to support the global structure that we need to have. We have to have these foundations solidified and built around the world and sustainable. So that they can't just be like in one country, like what we're dealing with right now with Taiwan being the 90 something percentile producer of cell phone chips. Like this is not something that's good, and we need to be able to have it diversified and sustainable around the world. So and I'm working with many different groups within governmental organizations around the world, and seeing how anxious they are to get into this industry and to find out how they can start moving their country into this technology is really interesting to watch as well.
Yeah, I think if you ask me, what I really study a lot about is supply chain. People think like, oh, you must like know all this AI machine learning stuff. Like, I know about AI machine learning. I know about data. I work on data. I work with AI machine learning data. That's my daytime job. If you ask me what I do as a hobby, I study supply chain. I study conflict. I study conflict based on supply chain. I
Mhm.
study all the historical conflict in terms of supply chain. Because when you think about a supply chain, you think about people consuming. But what you don't think about is the process in the middle, right? And that process is a lengthy piece that most likely is not even that relevant in you or anybody consuming a product or having that product accessible, right?
Mhm.
And this is where I go dystopian a little bit. As long as you have access, you don't think about it.
Mhm.
You had the
Yeah.
shortage of access when the chokehold actually squeezed, which is the Malacca Strait out in Singapore. Something happens in Taiwan. Well, not even the squeeze in Taiwan. You can think about dry drought season in Taiwan before COVID and how
Right.
COVID amplified that shortage. That
Mhm.
supply chain is a nightmare
It
if
is.
you don't know where the vulnerability points are. Remember that ship that got stuck in the Egypt Canal?
Yeah.
Brought the
That's
whole
terrible.
world to his knee to say, like, okay, we might not next week.
One ship. Like that's just
One
crazy.
ship.
Yeah. Yeah.
And if you don't think about supply chain continuously, it's okay. I do it for you.
Yeah.
uh,
Yeah.
Ukraine war has been devastating in our supply chain. So this is a
Mhm.
supply chain away from AI machine learning, right? So if you see the hustle and bustle in all these countries right now for semiconductor chips, either designing of it or manufacturing of it, or at least getting a good grip into the supply chain, there's a good reason behind that. It's because the supply chain vulnerabilities are becoming more real every week.
Oh,
And,
yeah.
like used to be back in the days, we used to say like, oh my God, things will change. Well, things have changed, and we haven't even fixed any. Well, we've fixed some of it. We're fixing some of it. And the
Mhm.
semiconductor chip situation that we have in White House, with the
Mhm.
CHIPS Act, with the investment that is happening in India, all around Japan, all around Germany. Some of the countries, they don't even know what to do. They're jumping in saying, how do we get our hands on these supply chain of semiconductor chips? Not because we have to manufacture it, but how do we secure our technology and how do we secure our infrastructure that will require those semiconductor chips? So what do we need to know? The
Right.
interest is very high level at this point, but we want to keep it that way. We want people to not even realize what happened in the supply chain, how the semiconductor chips was became mainstream. That we don't have to worry about that nightmare anymore. All right, people that are supposed to pay attention to it are paying attention. I think Robert Quinn is the person that we want to have this supply chain secured by because he knows the ins and outs of the supply chain at this point. So as long as the right people are doing the right things, we're good. As long as the user don't experience that shortage, as long as the user experiences like, hey, I never felt the interruption anywhere, right?
Yeah.
Good. That's the good news we had. But 2020 kind of threw that off to the chart a little bit. That became the outlier, and we don't want to repeat that. And that's why you're seeing lots of the movement. That's why me and Robert is talking about software and the hardware and how we can have this uh, uninterruptible user experience that are coming down the pipe.
Mhm. That's what makes it understanding the complete ecosystem
Yeah.
is so critical. And this is what I spend a lot of my time doing, speaking to governmental organizations. I was recently in Oman, speaking in an event there, talking about the semiconductor industry ecosystem. Like to understand supply chain, to understand apples, this is apples and oranges, really. Whenever you're talking about chips, um, the shortage wasn't in your your super advanced chip that's in your phone. It wasn't that chip. It was the old technology chip that's a 165 nanometer. So just to give it a scale, the chips in your phone are averaging around 7 nanometers. The old technology that is 165 nanometer plus technology, that's the chips that we were short. We weren't short the new technology chips. And a lot of these chips are being made in other parts of the world, such as Asia. And so that's where the chip shortage came from. It was directly related to Asia. There was many things that happened that could have that part of it. There was a fire at a fab. There was, of course, COVID happened. People weren't able to work. We had shipping problems. But this industry is so globally interconnected. It's incredible. We make these chips, for instance, when I was at Samsung, we make the chips here in Austin, Texas at Samsung. We throw them on an airplane, fly them back to Korea to be cut and diced, and then they get probably sent to another place where they get packaged. And then they get cut, diced, tested, sent to another place, packaged, and then sent to another place to be And these are, when I say places, these are usually countries that are diversified countries, and they're doing, then they go from Samsung's hands to Foxconn's hands to, the different companies that are making the chips and then putting them into your cell phones and into your devices. So to understand that the these this industry is so the ecosystem of this industry is so interconnected, and the dependence on the different nations is absolutely incredible. I mean, we carry these things in our pockets, and they're it takes like 15 countries to make one of these. I mean, if you break it down to the minerals, right? You're talking about, the mining of copper. You're talking about the mining of magnets. You're talking about the mining of different materials to be able to make these phones. It's incredible that amount of interconnectivity within the different nations that it takes to make this technology happen. And it has to be diversified. It has to be sustainable so that the whole world can depend on losing, like you said, what if a tsunami hits somewhere in Asia, or can we depend on, can we still support the world and still be able to lose a small section of this supply chain system? So yeah, it's incredibly hard to understand this ecosystem, because they are apples and oranges, and understanding the different types of chips that are made, and understanding how they're interconnected, and the nations are interconnected to be able to manufacture these products that we use every day. So it's so much to kind of wrap our brains around it. It's incredible.
Yeah, I can talk about AI machine learning all day long. And if I have to talk about the evolution of AI machine learning and skip the discussion of semiconductor chips, it's like not talking about the train at all. Like saying, what train? It's just an empty rail track, right? Um, that's what semiconductor chips is like. How important is it in the picture, right? Well, if your experience tells you that this experience is 10 years old, is because you have 10-year-old semiconductor chips. You're
Mm-hmm.
playing a video game. Quality sucks. Yeah, there's a reason behind it. The chips is from 2020, no, 2015ish, right?
Yeah.
You can
Yeah.
tell, like there's the UI, the user experience in the video games. You can tell, like the quality, right? Why is that happening? It's because it's coming through a narrow gate where all the pictures and pixels that you have in front of your screen right now is coming through a narrow gate, and that narrow gate only gets narrower as time passes, right?
Mm-hmm.
But these narrow gates, their capability of processing data fast enough and process volume of data all at once, not even like with the how many milliseconds are we talking about? Like less than 14 milliseconds? Like a blink of an eye is not even 14 milliseconds, right? Less than that, it's what needs to change continuously. So as you watch the video from 2015 and you're playing a video game and your screen quality is changing, is because every nanosecond they're sending out these video streams in your screen. And how does it come together? How do they you know change every few seconds? So that lag that you see, that the time that passes in between two different screen, is all based on semiconductor chips. So we can talk the whole world, or we can just talk about semiconductor chips, right? We can talk about the whole ecosystem, or we can talk about the semiconductor chips, right? Because this whole supply chain is just to say, how much data can you produce and how fast can you produce it, right?
Right.
So this experience that we're having right now, just within me and Robert and all the people in LinkedIn that are watching this, it's happening because of the semiconductor chips. This
Yeah.
wasn't possible just 10, 15 years ago, that we were able to put this much data into a LinkedIn server and have that LinkedIn server push out this much video content for this many people. I think LinkedIn passed billions recently, or no? I think
Yeah.
LinkedIn is still under 500 million or so, right?
Quite a few.
Anyway, that's a massive number of people.
Yeah.
And to push that out through a bunch of servers, was unheard of, right? And these
Mm-hmm.
are all semiconductor chips. That's
Mm-hmm.
why it's happening. So if you think the experience that you have today is enough, I'm sorry, I'm not satisfied with that, because next
No.
10 years of experience is going to be out of this world, like
Yeah.
alien technology, literally.
Let's see if we're going to. There was something like I heard a statistic, and don't quote me on this, but it was something relational to the sense of we're going to double the amount of data on this earth in the next 5 years. Can you imagine? Like, that's incredible. Like, how are we going to sustainably support this? Like, we have to make a lot of chips and a lot of servers to be able to support that kind of data. That's incredible, because if you think about the amount of data that just a Tesla makes is incredible. It's incredible the amount of data these new cars that they're producing as they drive down the road. But yeah, it's amazing.
So let's call this as a data processing, right? I gotta tell you, when there's data at rest, and there's data
Mhm.
in motion, and
Mhm.
there's data in usage. Data in usage, where the user experiences what data is, right? Because if you can see ones and zeros only, that is a terrible user experience.
Yeah,
And
that'd be bad.
that'd be really terrible. Like, how am I supposed to read this?
Right, right.
Like, where do I go to read that ones and zeros to figure out it just says hello in it?
As we look at the screen, like surrounding us, ones and zeros.
You have to
Yeah,
go somewhere else to figure out, like, what's that ones and
yeah.
zeros. So, like, that ones and zeros, that data at rest, um, it's it's your ability to take in that data, but you're not seeing the data at rest. As in, how much data is at rest right now? Because
Mhm.
if I have to call that data as a user and get to that data at rest through the data in motion, because the data will be in motion to get to me from a server,
Right.
wherever that server is, that has to be really, really fast. And that's becoming really, really fast,
Mhm.
because how far the data center is in part of the equation, right? If the
Mhm.
data center is within my state borders,
Mhm.
I will have sort of the experience that somebody outside of my state might not have, right? Because it has to travel that much of a distance. So that's just one example of it, right? So what should be concerning to most people is that when you have a data at rest and there's too much data, but not enough good data processing to have that data in motion, because whatever data you call is not the one you're looking for.
Mhm.
So think about that. So your user experience degrades over time because the data at rest is not being handled by technologies such as AI machine learning
Mhm.
and sophisticated semiconductor chips,
Yeah.
chips that will be able to say, you call for that data, I got you, no worries. But
Mhm.
that alone is not the solution, because your AI machine learning will have to figure out, and with high confidence and most accuracy, have to push that data through the pipelines and have the user see the right data.
Mhm.
Um,
Mhm.
this is
And
where AI machine learning and hardware all comes together to provide
mhm.
that user experience.
And don't
And
forget the don't
really,
forget the
yeah,
architecture too.
there's layers.
the, the architecture for the so there's another layer beyond just the manufacturing of the chips. It's the architecture of the chips. And so we're moving into neuromorphic computing and being able to use that to increase speed, reduce electrical usage, which reduces heat, which reduces cost. But yeah, all of that, it's incredible.
Yeah, because more data is processing and longer is processing the data. So the PPA really matters, the area of the chips and how much power is going through it, and
Mhm.
how much is it processing, right?
Mhm.
So did I say PPA correctly? Area, power, and processing, correct? Anyways, I might have to check that last P. I'm not sure about that one. But
It's,
the amount of processing that you do and how much electricity you have to use within that small area and how much it heats up will determine what the data quality is. So if the data
mhm.
quality degrades because you have a big area, but you have tons of energy going through it and it's heating up
Mhm.
and there's no way to cool it, well, that's the reason you have to keep the data center in a cool place, because you have to always cool these semiconductor chips down, right? So the
Yeah.
more advanced the semiconductor chips doesn't necessarily mean that, oh, you can just push more electricity through it and then it will process that much more data on transistors. Well, that's not the case. You have to actually create an environment where within a semiconductor chips, you don't produce that much heat, And if you don't produce that much heat, you can save on electricity, save on your cost of data processing. At the end, your user experience is still as solid as it should be. These are the races that we're having worldwide at this point, because
Yeah.
this digital experience that people want for the next 10 years is not going to be what I have today.
No.
It's going to be
No.
totally different. Artificial intelligence, augmented reality, virtual reality, mixed reality, in-device AI machine learning capability. So your AR, augmented reality, is not reliant on internet connection for it
Right.
to work, right? So your augmented reality will have AI machine learning built into the device. So that way your augmented reality is processed within your device. It doesn't have to travel thousands of miles and come back to you.
Yeah.
Good example of it is Siri and Alexa. Siri and
Right.
Alexa is super smart. Only reason
Yeah.
they don't work really that great is because they cannot process that conversational piece that you would like to have with the Siri and Alexa.
Yeah.
It's fun to make fun of, but
Yeah.
if it was to work, it would work like Jarvis in Iron Man, right?
Yeah.
Because
I
Jarvis
keep
in
I
Iron
keep
Man,
saying I keep saying I want ChatGPT in my Alexa.
yeah, yeah. I mean, text is one sort of data that is coming in, but even with ChatGPT, you see the lag, right? That
Yeah.
few seconds it takes you, you're like, okay, come on, man, a little bit faster.
Hmm.
I
Hmm.
mean, you cannot just get enough of ChatGPT. Even 7 months later, you're like, I think we can do better than that, right?
Yeah.
Because now that we have the thirst for it, now we want more.
Hmm.
And that's what's happening. And I'll tell you one thing that somebody might bring up is that, like, well, what is it? What's the cost to the environment for this, right? Unfortunately, there is a lot of cost to the environment, and we have to measure all sides of equation here, and to say, uh, how do we provide this without costing too much for the environment, for the next generation. So there's a whole
Hmm.
lot of equations to do, but one thing I will say is that if we are processing information within device rather than through internet, I
Yeah.
think that might save us a lot of these environmental questions that we're asking right now, which is that there's analog chips and digital chips combined. They can perform some of the tasks that a digital chips cannot by itself perform, which is coming down the pipeline right now. That's a great news for environment. But we have to keep all sorts of equation in mind in order to proceed with the user experience that we want. Because, of course, we want to get greedy, but at the same time, we're going to have to check ourselves to say, is it worth the cost, right?
Yeah. Yeah. And edge computing, bringing in that edge computing into, processing that data on the edge versus in the servers, right? And that's going to be big, and that's going to be a big convergence in the near future.
Edge device is not only just cool because that's something that performs really really fast, but if you think about the application of it in all layers, it's very secured. Unless somebody can hack
Mhm.
into your device actually and pays you specific attention to say, Asif's device is what I'm going to hack, not massive hack like hack into the server where my information lays, right? It'll
Mhm.
be difficult, right? So
Mhm.
difficult to specifically target. Instead of spamming everybody, you will have to go and target each device
Yeah.
with this information. So you want edge device. You want
Yeah.
edge device that has AI machine learning, or let's just call it specifically GPT,
Yeah.
your pre-trained transformers, right?
Transform.
Your pre-trained data is already built into the device. That means when you engage with this data, these data are able to interact with you, without really traveling the internet, right? The data
Mhm.
in motion
Right.
piece. That data in
Di-
motion is within the device. That short space that it has to travel in order to get you the
Mhm.
experience that you're looking
Give
for.
me a rundown. I just for there's so many of the people that view the show that are operations within semiconductor fabs, right? There's so many people that don't have that depth of a knowledge of understanding. Can you give me a basic rundown from a software perspective and AI perspective, how AI lives in the edge and what is the edge? Can you give more of a detail on that? Because I got a great summary of that from one of my a person that I interviewed a while back ago, but I still am wrapping my head around some of that because it was quite an earful. It was, but
Yeah.
I love to hear it again from you, and maybe you have a different perspective on it.
Um, so I think this is a guide thing, but we talk about history on our browser, right?
Mm-hmm,
That's called cache.
mm-hmm,
This cache is what's holding all this information, so that all the things that we do within our computer in device, right? So there's a cache of information about us within device. So the reason that they do cache is to say, instead of going back and finding that information over the internet in a server that's out in Ohio somewhere, far away from where the device is, we can go into the device and find that information faster. So as you're typing in the information, all of a sudden it's popping up. That's cache. Cache is in memory, right?
mm-hmm.
So this technology was game changing. Like I said earlier, user never had to find out how user experiences would suck really, really bad. But as the user experience increases in numbers and satisfaction grows, they don't really realize how cache was a big deal, right? That changed a whole lot of experience. So another example of that is to have cache in your local area. So when you watch a Netflix show or a movie, instead of traveling all the way to where Netflix servers are, you are traveling to a server that's near you.
Hmm.
So
Interesting.
that's cache there because Netflix knows in this zip code, this many young people will watch this many, whatever the young movies are, teen movies, right?
Sure. Right.
Or what do I watch? I watch like some documentary or something like that. It would
Mm-hmm,
know. It would know who watches what and how to cache that into local areas, so that way you are able to access it faster. And there's lots of algorithm that goes behind it. By the way, that adds to your user experience, right? So where am I going with this cache story is that if it is that cool with that little time frame that you are spending, say, like, say, for example, you want to pull up an old 1980s movie, it's not cached in your local area. You're pulling up
right.
that 1980s movie, it will take about few rounds of turning, right, in Netflix
Mm-hmm, mm-hmm,
for it to get to you.
mm-hmm.
But you don't mind that because you're not looking for it that fast. But if hundreds and thousands of people are trying to get that same movie at the same time as you might have to wait a little bit longer, right?
Yeah.
Because it's targeting that same server, and then that server has to work really hard and to provide that movie to hundreds of thousands of people, which doesn't
Mm-hmm,
happen with 1980s movie. But a recent movie will have that cache set up so that was in the local areas, right? So these caches are distributed all around. If you want to look up a company called Akamai, which if you compare it to other companies like Google, Verizon, or other companies that are like really popular in the internet,
mm-hmm.
they wouldn't be able to do half of their work without Akamai. Akamai
Wow.
is what makes your internet the way you see internet today. And
Really?
Akamai is
Wow.
nowhere near anybody's radar unless you're thinking about caches, right?
Wow. Yeah.
So you got to look up Akamai. And Akamai does CDN, which is content delivery network. So when you have a content that has to be delivered to massive amount of people in short amount of time, you have to do the CDN, content delivery network, all around the country within zip codes. So that leads me into the edge computing, right? That's what
Mm-hmm,
edge computing is about, sort of. Lots of the edge computing is that if you don't need the data 24 hours a day, but you need it really, really fast, where can we store that? So edge computing will be for your password login, your security login, things that are happening in real time, really fast, within a short distance of traveling for the data, right?
mm-hmm,
That edge computing, if you take that edge computing from cache to edge computing, now from edge computing to edge device,
mm-hmm.
that data is stored within the device rather than that data has to go out into the ether somewhere in Ohio, somewhere in Virginia, somewhere in Utah. You're accessing the data from your device. And how do you make data compact enough to put that inside of a device? Is the ultimate challenge. And
Right.
if you have a good AI machine learning system that can train itself and train it, remember that pre-trained, it's pre-trained data that
Yeah.
has the capability of engaging with you in a personalized way without traveling the internet. There's tons of benefits to that because your personalized information is sitting inside of the device rather than out in the server that could be hacked and somebody could reveal your credit card information or your informations that are very sensitive that you
Mhm.
wouldn't want it to be stored in a server out in Ohio or
Right.
Utah or Virginia, right? Because that's not in your control. Your device is in your control.
Mhm.
And if you could do that edge device computing based on pre-trained data, what that means is that some of those data, let's call it 20-80 rule, right? 20% of it is your data, 80% is pre-trained sent to you by the device owner.
Mhm.
And by engaging with the 80-20 numbers, by calculating those numbers and personalizing it, you are able to experience augmented reality, virtual reality, or mixed reality, or just any sort of reality, even within your business organization, within your network, the server that sits in your basement, you're able to engage with your own data without anybody else seeing it. It doesn't travel through internet, and it's very secure from all the vulnerabilities of servers that you don't own, right? So
Mhm.
that's the edge device from cache to edge computing to in device, right?
Right.
Um, how did I do? Give me a grade.
That's incredible. That's great. I love it. That breaks it down very well. But in my world of semiconductor manufacturing, that translates to one thing: more chips. We need more chips. We need more advanced chips, and we need the advanced AI architecture that's going to neuromorphic computing and other types of computing to be able to run these chips, to be able to use the architecture to be able to make these chips, to design these chips and to manufacture them. And so more chips, more chips, more chips. And this is the foundation and this is the foundation of all of it, where it all lies. Whenever I think about the where we're going with this technology and how this technology is changing the world that we're living in and the rapid change that it's happening right now. It's being able to see how that's happening is it's amazing. But yeah, I very good. I like that that translation of edge computing because it's it's a lot to wrap your mind around to understand what where this technology is going, how things are going to be changing in the near future, and a great conversation I had with Navid, Dr. Navid. He's CEO of Rapid Silicon, I believe. Um, he's working on FPGA, which
Oh,
is
yeah.
incredible. This guy's going to change the world. Like so, you think of a chip that is open source, and the software makes the hardware. So build a chip, send it into space, upload a software package to it, and the digital inputs and outputs conform to make the physical hardware in the chip change. And between that, edge computing, and many other, this new, the way that we're going to be developing the new technology with the architecture, it's going to be amazing to watch. And the FPGA is interesting to me because it's going to increase the speed of the output that we can build these chips at. And so we're going to see a very rapid change in the speed of technology and the way that it's coming at us, because you're going to the development time frame will go from 3 years to a year, to be able to develop, manufacture, and put an IoT device into full production to the world. And so this will be huge. The FPGA, ability to use the FPGA, and the ability to use the edge to handle that data. It'll be wild. It'll be wild to watch. So
Uh, we have multiple options, and not all chips will serve all the purposes, but the chips that are serving specific purposes will be in demand specifically for AI machine learning. So if you see the White House Chips Act, you know, even if we layer it for why they're going about it, geopolitical purposes, supply chain purposes, or just to say, manufacture in US, whatever the case is, these chips that will be developed. For example, FPGA is really good in military use cases, space
mhm.
use cases, or use cases that are field tested, right? So it's FPGA field, right? So some chips that are like an edge device will have capabilities that is unheard of, right? That ability to Jarvis-like experience. We will need specific chips for that, right? We will need specific trained data for that. One of the things that we just said is that like we need chips, and we need more advanced chips. Uh, what we really need on top of that is more people to specifically engage on developing these chips. Like
Yeah.
if FPGA chips is to be the next level of chips that we have to manufacture, and we have to mass manufacture it, not only for security purposes, we need to have it for educational purposes. As in, how do we find those use cases and say, well, look, that siloed use case that you have, that you've been using a 100 plus nm chips for, let's look into FPGA for that. How do we push FPGA to do the work that you cannot find a replacement for that, 90 nm chips, right?
Mhm.
What do we do, right? But the hardware, the device that we hold in our hands will shrink in size.
Mhm.
So the hardware that we are used to so much today will, and I say it again, will disappear, as in your monitors will disappear. Your monitors are no longer going to be relevant for
Right.
your user experience. If you are in augmented reality, and if you're looking at what Apple is doing with their augmented reality goggles, which
Mhm.
cost hefty penny, but that's the birth of that next 20 years of human innovation. You don't need monitors anymore, and you don't need a chips inside of a keyboard, because you won't need keyboard anymore. Your
Right.
keyboard is no longer communicating with Chat GPT, but it's communicating with a voice GPT,
Yeah.
right? So
Yeah.
that voice GPT is the ability to say everything you can type in, I can take it as a command from your lips.
That's crazy.
That means your hardware will uh, disappear, but it will disappear behind the walls, as in the
Right.
speakers around your house, the microphone that will listen into your discussions. I mean, I mean it with edge device. Nobody else listening in, right? So this kind of capabilities that are coming in, FPGA chips could have certain use cases. GPUs will have certain use cases. CPUs will have certain use cases, but they
Mhm.
will have to be mass produced and used for the semiconductor chips purposes specifically. So you have to find wide set of data and narrow set of computation, and good set of use cases, right?
Yeah.
As in,
Yeah.
not all use cases will have the same chips, and not all use
Mhm.
cases will have GPUs and CPUs behind it.
Yeah, chips are really apples and oranges. They really are. There's just so much variance between. People say, oh, we're having a chip shortage. There's such a difference between different styles of chips. That yeah, it's an endless amount of change that you can make in chips. So wide varieties. But you were talking earlier about different chips and the different abilities for the chips to be able to handle heat and to be able to dissipate heat. So within the uh, automotive industry, where we are seeing a lot of EVs, electric vehicles, the charging stations. Um, you, I don't know if you've got a power charger anywhere, but you notice that the power charger for your computer has gone from this brick that's this big
Right,
to this little square that's this big.
right,
Why? Because of the new chips, the new power semiconductor chips that we're making, because it used to take an area this big to be able to dissipate that heat of the power that was created within that brick. Now we're able to do it with this little box now, and your Apple laptop or whatever, you plug it in, and now it's so much easier to carry around. I hated carrying that giant brick around. But it was like, what's the point? I've got this laptop I can carry everywhere, but I got to carry this incredibly huge brick with it everywhere I go. But power semiconductors are going to be very interesting to watch. You can make power semiconductors out of diamond, you can make them out of gallium nitride, or you can make them out of can make power semiconductors out of silicon carbide. And silicon carbide is what Wolfspeed and a bunch of other companies are really, the technology is advanced enough that they can really use these for producing a lot of chips at a high output and getting great yields. And it's the technology in silicon carbide has done very, very, very well. And a lot of investment going into it. But yeah, power semiconductors are interesting, and seeing how they're going to change the world in the near future as well.
So we finally found a good use case for diamond. Um,
Other than the finger, right?
what to
other,
do with
other,
all those diamonds? Let's do
yeah,
something with that.
right, right. And now we can now we're growing diamonds. We don't the processes,
Synthetic
one of the
diamonds, yeah.
processes that we use in semiconductors, CVD, chemical vapor deposition. And this is the process that they use for growing diamonds, is chemical vapor deposition. And so it's it's an interesting it's high heat pressure. It's you're able to grow these diamonds, and there's man-made diamonds and there's natural diamonds. So yeah.
And you were hitting on a point that earlier I thought performance was process, so I think I was in the neighborhood somewhere, but the power performance area is so small at this point that if we go any smaller, we'll end up in zero point 0.5 of silicon, and then that's how big a silicon is. So if we're down to like 1 and 3 nm at this point, if we go a little bit more, we will literally lose an atom that is silicon that is supposed to run the operation right within that
Right.
area. So actually, what they're you're in a crowded city when they're going 3-dimensional. So instead of having just a flat 1-dimensional semiconductor chips, they're going with FinFET, which is
Mhm.
stacked semiconductor chips that looks like a shark fin, and kind of looks like a shark fin.
Three-dimensional.
3-dimensional. So they're it's like a Manhattan. They gotta go 106th floor above, right? But we can keep doing that because that's just not what's sustainable for everything. Like we were just talking about, some use cases you just can't have that sensitive of a semiconductor chips, right? FPGA is one of the alternatives, but if FPGA or those sensitive FinFET like semiconductor chips are not suitable for your use case, what do? You have to go to the diamond. You have to go find something very specific to your use case, and that's the world we're living in right now. Because if we don't spend money in research and development and more variety of chips manufacturing, we will get stuck in the supply chain chokehold in Taiwan, or some of the countries where the natural minerals and the rare earth elements will come from, right? So how do you secure that rare earth mineral elements, and how do you secure the supply chain? Look, we have to just have variety. We just have to have the option, just like we do everything else in life, right? Have these semiconductor chips plants built around the world. And that brings me to my next point, which is people. Again, do we need more people in semiconductor chips? I think just like AI machine learning, just like cybersecurity, I think it's a dire need in semiconductor chips industry to have more people engaged. And I think, Robert, you are doing a heck of a job in securing that interest from the generation that's coming behind us, to have them pick up the semiconductor chips as their career, because these technologies takes years to perfect, years. When I say manufacturing fab that will have semiconductor chips pushing out to the manufacturing shop floor, it takes years to build. And it's because that's how complex the manufacturing shop floor is. But if you don't have the people to run that complex manufacturing shop floor, that only adds to the years it will take to manufacture those. So I think people, Robert, is the next chokehold point beyond supply chain.
Yeah. There's a lot of people looking at this right now, including Washington, D.C., and it's a big problem. I was recently flying to Munich, and I was standing next to we're boarding the plane, and I looked at the guy next to me, and I was like, I know who he is. I don't know, can't put a pinpoint who he is. And I looked at his bag, and it says NXP on it. I was like, oh, he's the executive from NXP. And so we got into a conversation, and he was from Europe, and I said, what are you doing here? And he was like, man, I am here talking about labor. I am flying to Singapore to talk about labor, and I'm flying back to Europe to talk about labor. And it's like, this is a big, big problem. Everybody from the Washington, D.C. all the way down is looking at this, saying this is a big problem. We are doubling the size of the industry in the next 8 years. The average person that is a senior engineer in semiconductor fabs right now is 52. I think they said the average age is 52. It's a depends where you get your data from, but it's as high as 52, as low as 40 something. They're an aging group of people that are going to be retiring and very soon, especially within that 8 years of that we're going to be doubling the size of the industry. So this is a big you see this happening, right? You're doubling the size of the industry. Your average person is retiring, and there are zero students in the pipeline to come backfill these jobs that we need to be training right now to be able to get them to fill these senior positions in the near future. So I saw this and I started getting involved more and more and talking to more people about it. And I just kept hearing nothing, and just people like, yeah, we're gonna. That's a big problem. Yeah. Right, so yeah, there was the semiconductor industry is in dire need for staff. We need to bring in lots of people for the industry, but the problem is that we're doubling the size of the industry. We're the huge retiring bunch that are leaving, zero students in the pipeline to come into the industry. Kids just aren't interested in engineering anymore. They all want to be software engineers or YouTubers, and they just yeah, oddly enough, right? But the industry is in dire need for lots and lots of people to fill these roles that are coming up in the near future. So I created a nonprofit organization called SEMU. I had this vision. What if you could excite these kids about the semiconductor industry? As an engineer, it was awesome because I was able to bring in these kids and these young college graduates, and we'd bring them into these billion-dollar facilities, these $21 billion fabs. You've got 500 robots flying over your head. You've got these giant machines that are doing atomic layer deposition with 6-axis robots running in them, and these robots coming out and picking up wafers and slinging wafers everywhere. And the technology is just, you walk into these fabs and it's hilarious bringing in these new guys because their jaws are just on the floor. They're just like, oh my gosh, the whole fab is humming. Now recall that you're in a clean room suit, and the whole fab is humming like a train engine, like you're standing next to a train engine. It's just an incredible experience being inside these facilities, and they it just feels like you stepped into a time machine. It really does. And you're just in a completely different environment. But to see their faces and to see how excited they were about coming into this facility and seeing this equipment and seeing $21 billion of equipment in a facility coming together to make these chips. To give an example, we had a row of tools. We called it $1 billion row because that row of equipment right there was $1 billion of equipment. It's incredible the amount of money that's involved in this. But the excitement is so fun. So I thought to myself, how can we excite the next generation about the semiconductor industry? If we could give this excitement, if I could give this excitement to the students around the world, we would have people pounding down the doors to come into this industry to be the next generation that's going to create and manufacture these chips. And they're like, my mind was boggled. How can I do this? So I created a nonprofit organization. My vision is to build a 52-foot semi. I want to build a 52-foot semi that's going to have expandable walls. You're going to have 1,000 square feet of space inside this semi. I want to take this semi to middle schools and high schools all around the country. And I want to be able to give this Disney World experience to these kids to excite them about the semiconductor industry and give them this where they can go home to their mom and dad and say, Mom, I learned about semiconductors. I learned about atomic layer deposition. I learned about nanomaterials and nanoparticles and atoms and it's exciting to me. It's really exciting. And it's amazing to me that this world is made up of these nanoparticles excuse me, and so many of the people within this world have no clue what that means. Like they have no idea what an atom, like what the structure of an atom is, how small an atom is, and they don't understand the atomic the they're not able to quantify really what does it mean when we're saying that we're building semiconductor chips at 7 nanometers or 3 nanometers. 3 nanometers is 21 atoms wide. You're stacking atoms essentially, right? And that's what we're doing and to make these computer chips nowadays. So I want to create this environment that kids can get excited about it and then bring this unit to the schools all over the nation and get them excited. I've done a few things already. I'm working at the University of Texas. I've worked with, I've got a few other organizations that I'm putting together. I've brought some kids to a facility where we suited them up. We suited up 10 kids, taught them in a class about, plasma and physical vapor deposition and atomic layer deposition and what all these processes mean and how we make the microchips, and then brought them into the fab. They actually got to see us strike plasma in a tool. That was really neat. But it's exciting and it's fun to watch this industry and to see these kids getting excited about it. But it is worrisome at the same time because so much of this technology that we're developing nowadays that's going to be coming at us at like a tsunami in the near future.
The world actually for last 70 some years since that vacuum semiconductor chips. Is it a light bulb? What was that word for the vape? The semiconductor chips is a light bulb. One of the original ones.
The transistor bulbs.
Transistor bulbs, exactly. That's the word.
Yeah, vacuum transistors. Yeah.
Yeah. So if you think about it from that perspective on, the semiconductor chips has been running this world for 70 some years at this point.
74. Yeah.
74. So if you want to say how much longer, it's only evolving to a point is going to the quantum. So you want to get excited about quantum computing, which is the only hardware that we have to address and get to next. And you're not focusing on semiconductor chips because you're so busy thinking about quantum computing. Yeah. Well, if you're not thinking about hardware, semiconductor chips, and quantum computing in the same sentence, I will invite you to revisit semiconductor chips because AI means nothing without the quantum computing hardware. And that's the next level of semiconductor chips because that's the hardware that makes all the software possible.
I tell you what, if I was 18 again, I would be going into quantum physics right now. Like I just can't.
If only we had a time traveling machine.
I can't absorb enough quantum physics material. It is just, oh my gosh, it's so exciting. It's so incredible.
Easier to explain quantum computing to anybody is to say what we have today is not natural. Zeros and ones are not natural. That's not how nature works. Nature literally works on quantum, as in it has a flat direction and it can travel anywhere. Zeros and ones does not travel. Zeros and one is a gate that stops things from moving inside of transistors. That's not natural. What the natural is quantum. So when we go quantum, which if you think I'm bluffing, look at Google. They already released their 2020 version of quantum. That quantum only has increased on its capability in the last 3 years to a point that I don't think it's going to be 2030. I think it's going to be quantum right around the corner. However, if you're not paying attention to AI machine learning, because AI machine learning is already behaving what a quantum computing is supposed to behave like, the semiconductor chips that we have, they're able to perform to the level of quantum computing. So that quantum computing that is coming around the pipeline, we are definitely building a whole lot of bridge, which is AI machine learning bridge, the 3nm, 1nm semiconductor chips, processing of those data, the performance of those data. They're preparing for quantum computing engagement, right? Because all things are heavily reliant on quantum computers to take us to the next level, right? So the supercomputer that we have in Tennessee, $200 million supercomputer, that's quantum, right? So get in the line. Get in the quantum computer. You need to be in that pipeline if you're interested anywhere near AI machine learning semiconductor chips. Get in the line. You have to be in this train for sure.
Yeah. There was something the other day that I heard that just made me really, as a quantum physicist, talking about like there are two things in existence: electrons and matter. I was like, oh wow.
Right.
That just is a lot to wrap your mind around. It really is. Like you have electrons and you have matter. You break down an atom, and within an atom you have a couple of protons and you have electrons. And like, I mean, to understand that and to under I'm always looking for the answer, right? I'm always looking for what is okay, but why? Why is this happening? Why does this do this? Why can I touch this pin? Why? I don't understand that. Like, what makes up this pin? Where do these materials come from? It just kind of blows my mind as, I talk to family members and other people that just think that computer chips are just magic. They don't understand how it operates, what happens, how it's made, and it's not important to them. Uh, it's very important to me, and I think it's very important to you to understand how things work and how they operate. But this new generation better be thinking. They better be using their heads. It's not just a hat rack. You better be thinking in deep. Yeah, people think about. They tell me all the time. They're like, "Oh, you're overthinking this," and I'm like, "No, you don't get it. Like, I'm not overthinking it. You have to think about it a little bit deeper to really understand what I'm talking about." But yeah, quantum physics, quantum computing, and this future will just be amazing. So.
Well, I just want to say that never trust an atom because they make up everything. So, with that being said, Robert, I am like super inspired at this point after having this hour-long conversation with you because that's the purpose of this weekly webinar is to get the message out. But in the same point, I'm getting inspired by these messages because I get to have guests like you and engage in conversations like this because the innovations are coming down the pipeline and it's improving people's lives and improving processes, improving the technology. It's improving all sorts of industries that we can see that are, just very hard to control their inputs and output, right? Control that process. So how do we improve this process? How do we improve people's lives? And how do we improve this technology as a result is the ultimate goal of this discussion. So yeah, I think if people don't know, they just don't know. As long as they're still experience that user experience better than how they previously experienced it, and at the end of the days, at the end of the years, we can say like, I was worried about the wrong things. I'm okay with that as long as I was worried about the wrong things. As long as what I worried about does not become a reality, which is that this fear that AI machine learning chokeholds, the AI machine learning winter, which AI machine learning winter has come and gone many times, like for the last 70 some years. My worry is that the semiconductor chips is that choke point for AI machine learning. It will go through the hype cycle and it will flatten itself out and it will curve out eventually because we're not able to keep up with the demand of semiconductor chips and we haven't been able to engage with quantum computing. So with that being said, I know I just expressed my nightmare as a departing thought here, but I want to hear your departing thoughts, and hopefully it's better than mine.
That's great. It was great seeing you, Asif. And thank you so much for putting this together. It's amazing. I love talking to you and hearing about you, putting your mind, converging our minds and talking about you and I have gone, off script. We have gone just for hours talking, and it's always so much fun to hear your perspective and to hear, so much about the AI, ML, and all of this, how this convergence is happening, and how all these technologies are coming together, and where the world's going to be in the near future. You and I both have kids, and I'm constantly going, oh my gosh, what is this world going to be like in the next 35 years? When my kids are my age, what is this world going to be like?
Right.
Is it going to be good? Is it going to be bad? I can't tell you. I can tell you it will be extremely different than what you and I know today. It will be light years different than what we know today. And the speed of technology is just going to accelerate parabolically into Infineon. It's going to be incredible to watch this technology convergence happen in the near future, and thinking about where our kids are going to be living and how they're going to be living in this world, and what it's going to be like. It's going to be very, very different than what you and I know.
Give me some hopes, Robert, and I love you for it. So I'm looking forward to our next conversation, hopefully sooner than later.
It's great talking to you, brother.
Thank you all. Thank you, everybody, for listening in. I hope you enjoyed it. Tune in every week to our weekly webinar. And we're looking forward to engaging with you and hearing your comments and feedback. And hopefully, you've learned more than I've learned so far. Thank you.